Do you want to laugh? Do you really want to laugh? Then solve the numericals of binding energy and mass defect. Brilliant, easy, and you will find it much more entertaining. So let's understand with the first sum. Okay, consider a nuclear reaction where X with mass number 100 giving you A with mass number 110 and B with mass number of 80. Now the binding energy per nucleon of X, A and B is 7.4, 8.2 and 8.1 mega electron volt respectively. What is the energy released in the nuclear reaction? Energy released means E is equal to mc square, where m is the mass defect. What is the mass defect? First it was heavy, now it became light. That is the mass defect. That is what we have to calculate. So let us start with our question with the given. Well, given is this particular beautiful equation. Also they have told there are number of nucleons in X, that is 200. Number of nucleons in A, 110. Number of nucleons in B, that is equal to 80. Well, not just this. Binding energy for one nucleon of X is 7.4 MeV. That for B, it is 8.1, for A it is 8.4, X it was 7 point something. So this entire idea says what we have to find energy released. And if you want to find energy released, the solution is very simple. For the element X, first understand what is the binding energy. Now, how many nucleons are there? 200 into per nucleon 7.4. You multiply them and you get the answer in MeV. Big deal. For A, similar step. Binding energy is nothing but number of atomic mass, number of nucleons into binding energy of one nucleon. So that gives you around 902 MeV. Then the similar thing for B, the binding energy is equal to 80 into 8.1, that is equal to 648 MeV. Now. Energy released in the reaction is equal to 902 plus 648 minus 1480. That is equal to 1550 minus 1480. That straight away comes to 70 mega electron volt. What was that? Yeah. Nothing much. Anyway, a little bit more challenging is the mass of neutron and proton are given as so and so AMU. AMU stands for atomic mass unit. Now the neutrons and the proton combine to form the helium nucleus. How it combines? Let's have a look. And their masses are given as, the mass of nucleus is given as 4.0015 AMU. Now what is the binding energy of the helium nucleus thus far? And they have given the basic conversion 1 AMU is equal to 931 MeV. Let's understand. Given mass of neutron, okay, fine. Then mass of proton, fine. Then neutron and proton will give you helium. My dear students, helium has 4 atomic mass. If I simply combine one neutron, one proton, dear students, what you will get is simply nothing but just half the helium, which is not possible. So here we have 2 neutrons and 2 protons, which will combine to give you one helium nuclei. And mass of helium nuclei is given as 4.0015 AMU. And 1 AMU is equal to 931 mega electron volt. So what we have to find is, we have to find the binding energy of helium. Solution is very simple. First find the mass defect. So mass defect is twice the mass of proton plus twice the mass of neutron minus mass of nucleus. So what you get is twice of 1.0087 plus 1.0073 minus 4.0015. That belongs to the nuclei. Multiplied, you will get AMU. Now energy required or equivalent to 1 AMU is 931 MeV. Okay, so since binding energy is equal to energy equivalent of mass defect, therefore binding energy is equal to 931 times the mass defect. And what is the answer? 28.4 mega electron volt. Now, are you happy? Or more than happy, are you really laughing? Yes. Energy, if they ask, it's from mass. If you want mass, find the mass defect. If you want to find mass defect, the mass of the left hand side minus mass of the right hand side is your mass defect. Simple, sober, easy. See you all in the next numerical. Bye.
particles are there.